So good morning all, good afternoon or good evening if it's already the evening where you are located. Welcome to this virtual conversation dedicated to the implications of additive manufacturing for the energy industry. I'm Katie Sin, the managing editor at Additive Media, and I have the honor to moderate this conversation between our three experts. So the panel discussion aims to help you understand the energy challenges faced by industries and how technologies such as AM can play their part in addressing them. The panelists are also here to respond to engineers' concerns regarding the right steps to take at the manufacturing level, to discuss the user perspective and how AM solutions provider can address them, to provide key advice to companies that want to explore the use of AM within the energy industry, and obviously, they are also here to answer any questions you may have regarding this topic and even more. In this vein, I would like to invite you to note all the questions you may have during the discussion in the chat so that I could read them later for the speakers. So I will now give the floor to my panelists so that they can introduce themselves and the company they are working for. So Steve, maybe can you go ahead?
Hello everyone. I'm Steve Nardon from NG Laborlec. I'm working in additive manufacturing since 2014 for one of the competence center of the NG group. And NG is an electricity utility, so operating assets, but also providing industrial services.
I'm John Oakey. I'm Professor of Energy Technology at Cranfield University, where I've been for well over 20 years now. I am involved in a range of different technical areas, but my background is in materials. And in that capacity, I also am a member of the ETN Global Main Board, where I look after the areas of materials and related topics. Currently, my main research interests are to do with hydrogen production and electric vehicle charging, which are clearly high priority topics for the energy sector. So thank you very much.
Yeah, thank you, John. So we are still waiting for Sébastien, who may have some network issues to join the panel. So we are going to continue the conversations, and he will join us and introduce himself and Siemens Energy that he represents for this panel. So while we were preparing this panel, we came to realize that additive manufacturing in the energy industry is often mentioned interchangeably with the use of the technology in the aerospace sector. Are there any specific reasons that explain that?
I guess that's aimed at me, Ketty. The primary reason for that is the similarity in the technologies that are being used. And here the focus, I think, is mainly on high temperature, high pressure applications. So the rotating machinery, the turbines that are used in aerospace are variations of the similar machinery that is used in the power sector in particular. The energy sector is very broad in terms of the different technologies. So the similarity with aerospace really only relates to those parts of the energy sector that are using gas or steam turbines and the associated high temperature equipment. So that's where the similarity arises from, I believe.
Okay, all right. Steve, are there any other similarities that
Ali, I agree totally with the statement from John, but also I think that there are high quality requirements for the spare parts, and also from the aeronautics more than for aerospace, the high temperature and high pressure condition also requires high quality alloys, which are quite similar.
All right. Good afternoon, Sebastian. Hello? Sebastian, can you hear us?
Can you hear me now?
Yes, that's great.
Oh man, that's great. So I followed your entire discussion, and but you obviously didn't notice that. All right. Sorry for joining late. I had some technical issues, obviously.
Yes, it may happen. Don't worry, it may happen. But we are going to let you introduce yourself and Siemens Energy because, yes, We were just, finishing the small introductions. So please
Yeah.
go ahead.
Very quickly, yeah. My name is Sebastian Piegert. I'm working for Siemens Energy, pure energy player on the market, and my function in Siemens Energy is the technology field lead additive manufacturing. So I have a good overview, and I'm responsible to steer the strategic direction of additive manufacturing within Siemens Energy. And in energy, we have basically all kind of fields from renewable energies over the standard fossil technologies over transmission, and we supply the world with energy, and obviously we're in a big transformation phase right now.
Yeah. Speaking of big transformation, could you please explain the conflict between global energy demand and climate change, and why it drives the use of AM within this industry? Actually, I would also like you to, raise attention on the conflict between global energy demand and climate change, and how it drives the use of AM.
Yeah, I think you were aiming that one at me, Ketty. Conflict is perhaps not the way I would have put it. Traditionally, energy demand has increased with gross domestic product as our economies grow, and as a result, that has required increasing uses of fossil fuels, which has led to the release of more emissions and therefore the impact on climate change. But more and more, with the introduction of renewables and technologies that enable us to remove the CO2 from fossil systems, it's possible to decouple those things. So we can still grow energy production to help the economic development of countries, but at the same time reduce the impact on climate change. So that's been the great success of recent times, if you like, in the energy sector. Now, in the context of additive manufacturing, which is how you phrase the question,
yeah,
it's where this sector can take advantage of that new technology to help improve the efficiency of the devices we develop, to reduce their costs and to improve their reliability. So, and it does enable us, and will in the future, I think, to explore new opportunities in terms of methods of producing energy. But let me pass on to the others, because they may have things to add to that.
All right. I think that I will give the floor to Sebastian.
Yeah,
I can to share.
I can absolutely second what John just referred to. And in addition, I would say, as I mentioned, we are in a big transition phase, and in a transformation phase from a mainly fossil-based energy provision to a more renewable and sustainable environment. And this requires a lot of product development, where we'll need bridging technologies to come from a lot of fossil to very little fossil. And I think the versatility and the flexibility of additive manufacturing is exactly what can help to manage this transformation.
Okay. John, as an organization that gathers energy companies as well as the entire value chain of the gas or turbine technology community across Europe, what led to the creation of AM?
Well, the sector as a whole, and this is the turbo machinery industry and the related technologies that still provide the vast majority of electric power around the world. So let's not forget that it's a major industry.
Yeah.
Materials issues have always been a priority, not least because in different parts of the world, different fuels are used. The whole performance of the turbo machinery depends on the materials being reliable, and a great deal of effort has been put into that area. Now, if we look back over the past decade, the focus was probably mainly on advanced coatings and improving the protection of parts. That's the high temperature, high pressure sort of materials challenge. And it was mainly focused on that, but it's evolved from that into a focus very much on additive manufacturing now, which essentially takes some of the same concepts that are used for coating technology and applies them in a different scene where you can make whole parts.
Okay.
Just one thing to add, which I think is really important to the conversation.
Yeah.
We must have dispatchable technologies to balance the intermittency of a lot of the renewables that are in the marketplace. We cannot move completely to the use of wind and solar PV and the like for our electricity generation without retaining a dispatchable source of power, one that you can switch on when you need it to meet the peaks and to overcome the challenges when there's no wind or at night when there's no sun. So the continued use of turbo machinery is vital in terms of maintaining supply to customers and society globally around the world. And AM has a key part to play in helping us do that.
Yeah. Okay, so I've heard about advanced coatings. Sebastian, what other drivers can explain the use of AM in this vertical industry?
So as John already mentioned, a lot of effort goes into increasing the efficiency of our current devices. So mainly gas turbines. It's a highly complex product, and what drives the application is really the capability now to design for function. You have to take a step back and ask yourselves, what is the functionality of the part or assembly? And that drives then in the end also new designs that increase efficiency and reduce emissions. So that is what drives us mainly. Then, of course, you can look for cost benefits. That is a hard task, but sometimes that works. So you can really gain some low-hanging fruits and benefits. Then we also talk about fast technology validation. I mean, this is originally where the technology came from, and we can now do a lot of design iterations in very short time cycles. And lead time is also a big benefit for inventory reduction. So this is another thing where we are after to reduce our inventories, our stock, and debt capital, so to say. So these are, from my perspective, the main drivers to use AM in the energy industry. But maybe Steve, you have to add something. I don't know.
Yes, I was about to ask if Steve relates with what has been said.
Yes, from ENGIE. In fact, ENGIE is an operator. So basically, ENGIE operate assets, nuclear, combined cycle gas turbine, but also renewable. And on the other side, ENGIE also provide industrial services. So additive technologies for ENGIE has three main pillars. The first one, we included a kind of fleet of machines inside ENGIE just to understand the technology. Because as an operator, we know that equipment manufacturer will introduce new parts with this technology, and we have to know how this part will behave over time. Do we have to change the maintenance overall? What would be the degradation in those new materials? Because that's a new manufacturing process. So we need to generate in-house expertise to define also the operation and maintenance of the assets. On the second side, this technology is also interesting for obsolescence management. Sometimes for old assets, it's quite difficult to get new parts because we only need 1, 2, or 3, or sometimes the companies delivering this part are no longer existing. And so this is really important for us to use this technology, but not only additive, but in combination with others, to reduce the lead time and reduce the cost for the delivery of 1 or 2 parts. And the third pillar is also, in collaboration with equipment manufacturer and industrial customer, provide tailor-made solution, tailor-made design for specific application. And also, if we are talking about CO2 reduction, additive manufacturing can also provide new concepts to reduce the energy consumption, reduce NOx, reduce CO2. So that's also a way, that's an enabling technology.
Okay. Steve has dived a little bit in the manufacturing opportunities and challenges that I wanted us to address, but I would like first to call John's expertise as a professor of energy technology here, because we often heard professionals talk about the concept of clean energy technology. What is it, and can additive manufacturing be considered as a clean energy technology?
Well, the term clean energy technology is sort of means everything to anybody. I mean, it's a term that anybody could use.
Okay.
And different interpretations will apply. But if you look at it in the context of the environmental impact, whether it's to the atmosphere or it's through waste reduction, AM can play a big part in as much as it requires less material because it's an additive process. It's not like a conventional machining process, so there's less waste. Whether there's more or less energy required to make the part and where that energy comes from is another question. That could be fossil fuel derived. In fact, at the moment, it's quite likely to be. But in the future, obviously, that will diminish. So it depends, I think, how you're looking at additive manufacturing as to whether you see it as a clean technology. But it's part of the revolution that's taking place. So I think over time it will become cleaner, if you like, than perhaps it currently is, because it will be hard to claim any technology is 100% clean.
Yeah.
I think that's just being realistic.
Okay, thanks. Yeah. Thanks, Jared. So what type of AM processes do you see as promising for energy applications, and why?
I think that question's at Steve or Sebastian to answer that.
Yes, I was talking to Sebastian.
Yeah. So there's I think more than 2 handful of additive technologies around, and it's not so easy to pick the right one, probably. However, if I speak for Siemens Energy, the most widely spread technology and where we are also farthest with respect to the industrialization is laser powder bed fusion.
Yeah.
For some applications, electron beam powder bed fusion might also play a role, but laser is really, from our perspective, the most widely used technology. Then a very promising technology also for repair applications is laser powder welding. This is known since ages, since 2 decades, I would say. We apply this for repair applications. And if we talk direct energy deposition, we also need to talk about wire arc additive manufacturing for bigger parts, lower resolution parts, where we see higher build rates. So that has also a niche. And moving a little bit probably out of the gas turbine business, which is currently the main driver of additive in Siemens Energy, then we have also applications for fiber reinforced polymers, be it applications for the generator or potentially also for our wind turbines. So this is the mix I see, and per definition, you cannot play every technology at the same level. And we decided very much for laser powder bed and wire arc additive, I would say.
Okay. Any other AM technologies that you would like to mention, Steve?
Yeah, I fully agree with Sebastian. It's really related to the application, and laser powder bed fusion is really suited for small application with, let's say, fine features. Even there are other technologies that could also play this role. And then if you move to large parts for pre-products, you can use wire arc additive or direct energy deposition for repair. Also, there are new technologies combining a bit polymer as a binder with metallic powder. So you get also parts, but with different mechanical properties. So you need first to evaluate, let's say, the requirement for your application. Okay. What size, mechanical requirement, qualification, and also the regulation. Sometimes you will need, you are obliged to use an historical process because the regulation, the codes, the design codes does not allow you to use additive manufacturing. And then maybe another comment is hybridization, using multiple application for your need. Sometimes you will need to use a specific AM process for creating a big part, and then you would like just a small features, so you will use another technology.
So if I understand correctly, it means that it's a little bit difficult to assess just like this, by talking like this, the advantages and the disadvantages of each of these technologies.
That's part of the raise, what we call the raise awareness that we have to generate with people, because additive manufacturing is not the unique solution. There are so many possible solutions that has to be addressed and evaluated.
Yeah.
Maybe I just have one thing to add. There's also options to indirectly use additive for certain components. If you think about printing of dies or wax patterns for casting components, so you do not use the additively generated part directly in your product, but you can do useful things to speed up the supply chain in that case.
Yeah. Well, Sebastian, as you're speaking, I know Siemens bring a decade of additive manufacturing expertise on gas turbines and other rotating equipment. Could you mention some of the differences in terms of manufacturing between AM and the conventional manufacturing process?
I mean, generally, I would start probably from the other end and say, hey, there are no shortcuts. And this refers just to the due diligence we have to make. So just because it is additive manufacturing, we have to undergo the same harsh testing and qualification measures as we do for any other manufacturing technology. However, there are upsides, in particular on the length of the overall manufacturing chain. If you think about options you have to design for function and to do in particular functional integration. So what formerly has been an assembly of several parts could be printed now in one part. And by this, you can reduce the entire production chain for a component by a significant amount. One good example on our end would be a burner front end that we use for our medium-sized gas turbine developed by our colleagues in Finspång in Sweden, where we usually have, in the conventional case, 13 particular components that we need to join via welding and brazing to this burner front end. And we are about to transfer this into an additive process where we print this burner front end in one part, 100% functional integration. And this is generating the benefits. And there's other parts where we did this as well.
Okay. Yeah, Steve, taking the example of one use case as Sebastian just did with the with your colleague in Sweden, are there any challenges ENGIE faces as a user of additive manufacturing technologies? And even given the fact that you are a materials, expert, are there any challenges engineers and operators might face in terms of materials?
There are many challenges. So
Yeah.
that's a new process. For example, with conventional processes, forging and casting, there are 80 years of experience and return of experience. With this technology, it's quite difficult, and I think that nobody can tell what is the behavior of such material after 20 years of operation. So long-term duration and degradation behavior of those material are under evaluation now. There are a large amount of projects, and that's part also of what we try to do at ENGIE, try to evaluate with collaboration what would be the impact on the integrity on the long term. Also, what is really a challenge is also the acceptance of such technology, because that's quite new, even if it's already there. But having a part in a RNG unit we had to have a lot of discussion, present a lot of qualification dossier, and also speak with a large amount of stakeholders. But step by step now, we have a lot of parts now that are currently this kind of component, impellers, injector, valve bodies. Step by step, we are integrating this technology for us and for the industrial customers.
Okay. All right. Thank you. Thank you, Steve. I would like to hear all of you.
Yeah, I think one specific challenge that we are facing is if we design for function, design for the optimum, quite often we get rather complex shapes, and also what I just mentioned, to integrate the dysfunctional integration. This drives complexity of the parts, and if you think about this internal channels here, for example, in this printed part, there is a big challenge in the non-destructive evaluation of these components, and I think that is something which still is a big learning field to date. Even so, we have collected thousands and hundred thousands of hours on engines, but this kind of things that are keeping us busy still to implement the technology.
Yeah.
I may have maybe one other challenge, but that's more a generic one. That's about for additive manufacturing, we need raw material, and raw material can be metallic powder of wire or something else, but also the 3D geometries. And you will use the 3D geometries on the full value chain. When you capture or generate the geometry, then you modify it, then you put that in your system to prepare the production, then you will use the geometry maybe for inspection. And there are so many software tools available on the market, and sometimes it's difficult to have an integration on all these tools.
Noted. Sebastian, you're a software provider, so I hope that you've understood.
No, we are not anymore. Yeah, so we underwent this carve out, and Siemens Energy is not part of the Siemens AG anymore.
Okay, all right.
So there's
sorry
split
about
now.
that.
No problem.
So gas turbine seems to be the most widely known use case of AM in the energy sector. So what other applications can one explore with additive manufacturing technologies? And are gas turbines applications, the only proof of concept on the market so far?
No, I wouldn't say that's the only proof of concept, but since the gas turbine is a highly complex and rather expensive product, additive has pretty much found a sweet spot in this kind of application. And now it's about, when additive gets more mature, it's about to find more applications. And we have examples where we apply additive for certain components in the generators, for fuel cell applications, Wind power is just about to start these kind of applications, and what Steve just mentioned is the whole thing of obsolescence management is a big topic in our energy transmission division, and this is also picking up. So gas turbines still the leading application, I would say, in terms of value generation. But there is a whole crowd that wants to explore and getting more into additive.
Steve, any other applications that you want to mention, or John?
I think that for the energy, all the peripherals as well, pumps, but also all the electrical equipment for polymers. Because now there is also an obsolescence management for electrical equipment, terminal blocks, all these things. And we see more and more application about heat exchanger, because it's also one of the big topic related to additive manufacturing. That's the intricate cooling channels or features that you can introduce in a specific equipment. So it's really interesting for 3D application.
Okay. All right. So let's discuss the question of cost. Costs are, this is a big challenge. So does additive manufacturing have a real economic interest to date in terms of production costs and quality, or are we still assessing the capabilities of the technology for the sector? So that's an open question to all of you.
Well, the answer is very simple. Yes.
Okay.
There's quite a long way to go, and that's one of the reasons that ETN Global has an additive manufacturing initiative to make sure that the technology can deliver what the sector requires. And the others have touched on several of the critical issues. You've got to make a part that's equivalent to something which we've been making by other methods for many, many years. And I'm thinking of the higher temperature end again of the spectrum, which is, I guess, where the industry saw the most opportunity with additive manufacturing. And that's why the focus was put onto those parts, which were already very expensive, and therefore the place in which cost savings would be very welcome.
Yeah.
And you've heard some of the examples, the combustor, the burners and things of that sort, where there have been applications very successfully. But it's got some way to go yet to prove itself as producing parts of equivalent performance and reliability to those from the more conventional routes. And that takes some time, and we've touched on non-destructive evaluation, critical. So there's lots of parallel things that have to be fixed to enable AM to play its part going forward, not least making sure the parts can be properly qualified for use in service. So the standards and all of the other sides to the application of any technology have to be put in place. But at the moment, the big problem, as we've discovered in ETN events, is different manufacturers' equipment can lead to somewhat differences in the product quality. So there are issues that have to be dealt with within the additive manufacturing sector as well, in order to help us take advantage of the technology. I'm sure Steve and Sebastian will have relevant examples to add to that.
Definitely. Yeah, I think if I speak from a Siemens Energy perspective, if the costs would be totally off, I think this initiative would have died already. And by the end of this fiscal year, we will have qualified a total of 70 additive components. And however, looking or reducing the discussion only to the costs of components, that is a little bit short-sighted, because you need to look for the overall benefits of such advanced parts, and these benefits lie in the overall efficiency you can gain, on the emission reduction, fuel flexibility you might drive by additive designs, and the lead time reduction for inventory and obsolescence management. Yeah, so these are benefits that are often quite hard to put in numbers, but they are there, and just reducing everything to costs is not going towards the right target.
I see. Yes, I see. We have a lot of questions for the audience that I would like you to answer. Maybe we have to pause a little bit to answer some of them before we proceed. The first one is from Joachim. In which stage do you feel additive manufacturing contributes most, during construction, production, or in life extension of end-life installations?
Good question. We use additive, meanwhile, through the entire product life cycle. Fast technology validation is definitely something where we print prototypes, do design iterations, and can go in the real engine with a more or less validated design already. Then for new part production, we use additive. Yeah, I have mentioned the qualifications that are ongoing, or in some cases we print even a couple of thousand parts of the same manner already for our new engines. And we use additive also for service applications. So one application would be spare parts, which we provide also for rather mature frames, and we apply it to do repair. There is burner tip repair, which is a good example, but also blade tip repair, where we cannot only repair, but we can even upgrade the products through the use of additive manufacturing.
Okay.
So entire life cycle. I could not refer what is more important. I don't know. So
yeah,
everything.
Steve, do you want to share something?
From NG side, there are two ways for NG asset. Typically, that is during the operation maintenance and lifetime extension.
Okay.
Because in the design phase, we are not playing an active role. Let's say in the construction, we are not owning the design and the concept. We are collaborating with the original equipment manufacturer, but not for the NG asset, but maybe for the industrial customers. Then for product development, to speed up the development of the new product, or also to generate new concepts which are not which cannot be produced by conventional processes. That's the best way, because you start from scratch and you create something which is efficient and which is driven by the need and the function.
Okay, all right.
I think if you talk about this product development, so what additive can do, and what I observe is that we are more brave to try new concepts. So that is not only just organically grow to the next phase, but have a step change in the design levels that we see. So that's also pretty amazing.
Yeah. Thanks, Sebastian. I don't know if John wants to add something.
No, well, not really, but a comment that you have to recognise that the industry itself is going through the learning curve of how to use additive manufacturing.
Yeah, correct.
It starts off in any company within one group and then spreads rather organically to where the opportunities are seen to be. So it's not a question that's easy to answer, because you need to build that knowledge base and that understanding of the technology and the quality of the components that can be made from it, and then grow from that. And new ideas come out of that. So it becomes very much then a partnership between the user and the supplier of the technology. So I know that's what's been happening, certainly through ETN. A lot of additive manufacturing companies have been involved in dialogue with the likes of Siemens and Energy in taking forward our initiatives.
Okay, thanks. Yes, it's all about partnerships. I hope that they have been able to provide you suitable answers, Joachim. Please feel free to share any other comment in the Q&A chat. So I will move to the next question, which is one from Gotham. I hope I pronounced the name very well. What potentials does additive manufacturing have on battery production for EV? What are promising technologies in AM?
So what, can you repeat the question?
Yeah, sure. What potentials does additive manufacturing have on battery production for EV? I believe it is electric vehicles. And what are promising technologies in additive manufacturing?
Yeah. Well, I guess just a comment. That's probably a little bit out of the scope of our background for the people involved here. I don't know whether NG have interest in battery production or Siemens probably do somewhere.
The thing I see, but that's additive manufacturing covers a lot of things, also coating technologies and catalyst deposition. So in this prospect, having specific membranes, anode cathode with specific catalytic material with specific deposition process, that could also generate some innovative initiatives there. Okay. But there is another question related to rare earth material and also the feedstock itself.
All right. So the next question is the one from Victor Polar. Are you using HIP and thermal treatment as post-treatment to improve density and properties? That's one for Steve. I think
for our case, hot isostatic pressing, it's a specific treatment to close the pore, high temperature, high pressure. In our case, but for our case, if we speak about obsolescence management, the main driver is the lead time. So typically, hipping would require specific procedures, and as we are producing unique part every time, we try to avoid hipping, just to have a conventional heat treatment sequence. Otherwise, we should have to qualify a specific hipping process for a specific design. But in other case, for serial production, I assume that maybe Sebastian has another strategy with hipping.
Yeah, so generally, we do a proper heat treatment for all of our materials because we want them in a defined condition. As printed is pretty much, leads to a not so very well defined microstructure and to a respective chaotic material answer. And this is fixed by the heat treatment. Generally, we do hipping only with very selected and high-end materials, but not to close porosities, but to ensure that the parts will go through the follow-on heat treatments without any cracking. And in general, we try to set up our processes so that we get 99.8.9% density, and this then requires not hipping to close any pores or imperfections. So.
Okay. Victor continues with another question still related to HIP. For bigger parts, are you considering near net shipped HIP technology like in the USA?
From our perspective, not that I know of, no.
Okay, all right. Victor, I hope you're satisfied with the answers. Please feel free to share any comments and ask more questions in the Q&A. So I'm coming back with another question from Joachim. Do the panelists have any ideas or suggestions on how the adoption can be accelerated? How could the growth of experience or confidence be boosted?
from an operator point of view, I think that there are two difficulties now. The first one is about regulation and standardization.
Yeah.
For example, for the nuclear power station and for pressurized equipment, there are specific design codes which still not have the additive manufacturing processes and material related to that. So from an operator point of view, sometimes that's a pure no. No, that's not in the code. So we will not do that. It will take too much time. And on the other side, also, one of the main challenges that we have, that's the value chain. For specific product, you have a pre-product out of the printer, but then you will need heat treatment, okay? Specific finishing technologies, which sometimes are not well suited for the specific application or design. And so there is no full integration of all the post-processing step at the moment for specific application. And I'm always talking about unique part every time you need to requalify the post-processing step for every single design that you will print.
John, can you share something here?
I don't think I can add very much to what Steve said.
Okay.
Yeah, I think adoption has also something to do with success stories. If you successfully implement components, if you can show the benefit, and I think what helped us in the startup phase was really to form a dedicated team to push for it. I need to admit, at the beginning, it was really a technology push. We sort of try to set up the respective baseline technology, and it was an uphill battle. But meanwhile, there is acceptance in the organization, and in certain cases, we see now also a pull mode where we get more and more applications. But you need to go through this valley of death. I think that.
Yeah. I have another question. This one is from Rinel Foguin. Can additive manufacturing be used to reduce transportation costs and their ecological externalities by manufacturing products closer to the consumer in a decentralized manner? Oh, that was a tough one. Can additive manufacturing technologies be used to sustain the magnetic powers of dying motor magnets, making the motors more durable?
So there were a couple of questions in one. So with regard to the transportation costs, and I'm not so sure bottom line, because I mean that probably depends also a little bit on the technology. If I reflect that to the metal technologies we have in the portfolio, it requires a lot of post-processing, and you need to have this process chain in place, and therefore I'm not so sure if we can reduce the overall footprint by avoiding transportation costs. But in some cases, in service cases, that might very well be the case.
Okay.
Also, you have to bring the material feedstock on the production side, so your powder or your wire, so you still have transportation costs for the feedstock. And what we observe also, instead for metallic component, we observe big factories having 5-10 printers on a row for serial production, because as Sebastian said, you need a value chain there, and supply chain there, and one single 3D printer in specific location, that will be too costly, because you need a specific area, you need a specific or specific machine around it. So sometimes it's a dream, but it's maybe difficult.
Yeah. So our conversation was focused on additive manufacturing, but you mentioned at the beginning that conventional manufacturing processes are, still exist and are still here. So are there any other technologies that are necessary to enhance the production or manufacturing process of 3D printed parts for energy applications?
I think that it's what I can say for our products, at least if you look into wire arc additive or in laser powder bed fusion, as we mentioned, there is post-processing required, and that to close this loop from the printer into the, or to integrate this printing in the post-processing, that is still a challenge, and that is still, from my perspective, underestimated, because quite often the big lead times and also the costs accumulate in the post-processing chain when you try to depowder, improve the surface quality, heat treatment, hipping, and then the specific challenge for the complex parts about the non-destructive evaluation. So that's definitely something where additive and the conventional world, if you want to speak in that phrases, need to grow closer together.
Yeah. So post-processing remains, the holy grail for operators, no matter the application is.
And quality control also, no, because sometimes in the beginning, if you print something, you should wait until the end to check if the part is okay. That was in the past. Now, step by step, there is also some monitoring tools to evaluate a bit the integrity of this process. That's a joining process, like the welding process. So there are more and more tools available to give you also a quality card during the manufacturing process. And we need this confidence at the end.
So the topic is relatively new, I would say, for the industry in general. Is it already tackled at the educational level? At the education level, sorry, John?
Yeah, I mean, I think ETN has done a fair bit to open people's eyes to the opportunities with additive manufacturing, if that's what you're referring to. I mean, we've included it in workshops and conferences. We've had the likes of Engie and Siemens both describing their initiatives. We're promoting, as far as it's possible, collaboration with others in the sector. So building that awareness is all part of getting the best out of the technology. So ETN certainly is doing what it can in that area. Whether it's
Cranfield.
At Cranfield, we have a very strong manufacturing tradition, and additive features very strongly in this. In fact, the wire arc technology that Sebastian mentioned, there has been a massive development there for parts for aerospace and spacecraft applications, even that has come out of Cranfield over the last decades. So it's strongly focused within universities across Europe and across the world even. But probably there's not so much focus on specifically on the energy sector and the turbo machinery applications of it. That's more localized to specific institutions. I don't think there's an AM course for the energy industry yet.
Maybe it's too soon for that. Maybe it is too soon.
Yeah, probably so. But I think the partnerships we talked about between the energy companies and the additive manufacturing companies and the powder suppliers, as they grow, I think the case for having specific courses within universities to train people will be there. But that comes with time.
Yeah, I also believe that the coming generation of engineers, they will be quite familiar with additive manufacturing, but what we still observe internally is that there are still people totally unaware of what's possible at this point in time, and it requires a lot of communication, a lot of bringing people up to speed, and we totally underestimated the time it takes to move an entire organization into a certain direction. And I mean, that might be an even bigger challenge if you're as big as we are to get the respective awareness.
Yeah, that's correct. So what are the strategic imperatives you will note to foster the adoption of AM within this specific segment? You mentioned collaboration, partnerships between AM technologies providers and AM users or energy companies. What else could you mention?
I think that transversality is really important. For example, there are so many technologies, so many 3D printer machine manufacturer and brands, and it's really important to have a kind of minimum requirement, because if you have a machine, it doesn't mean that you produce great part. There is a big expertise behind, and from one machine to another one, even from the same brand, you can have totally different results in terms of quality. And this reaching a certain transversality in the quality is really important for the operators to gain confidence in the process and the acceptance.
Okay. So time.
I think we need to reach a state where additive manufacturing is considered just as another manufacturing technology. If we reach that state, then I think that's a big achievement because then we are fully accepted.
Thank you. Thank you, gentlemen. Do you have anything else that you would like to share for our audience?
I think this collaboration thought is a very important thing across the different entities, and in the end, it takes all of us to drive this additive manufacturing revolution.
Yeah.
So I think just to sort of take that comment forward, as far as ETN Global is concerned, we welcome any organisations involved in this webinar who believe they've got something to offer. Make contact with us, and we can talk about how we might make something happen around that. I think it's part of ETN's role to foster those sort of initiatives and to encourage them to develop in the future. So, let us know.
Thank you, John. Steve?
I think that was a great interaction, and we see, in fact, that we agree. The panel agree on, I think, on the technology, from different perspective, on the challenges, on the technical, let's say, improvement that have to be made, and that's also a good point, I think.
Thank you. Thank you, gentlemen, for joining me for this panel dedicated to the implications of additive manufacturing for the energy industry. It was really a true pleasure to have you here with us. It was a true pleasure to have the audience. Thank you for your questions. Thank you for joining us wherever you are in the world. And make sure you join our next panel dedicated to multifunctional part of our additive manufacturing. So I will close the panel now and wish you a very nice end of day. Thank you.
Thank you.
Thank you, Katie.
Yeah.